Hi, this is Ami, and in this video I'm going to talk about BGP terminology and concept. As BGP is a big concept and it has lots of things to cover, lots of things to talk about, so maybe it will be in 2 parts or 3 parts, I don't know. But we're going to work on that, we're going to talk, and let's see what will happen. Anyway, so BGP is another kind of protocol like the others. It's a routing protocol still, but there are some differences. On IGP protocols, interior gateway protocols like static routing protocol or dynamics like OSPF, REAP, EIGRP, Asyas, all of them are going to connect the routers inside the network, no matter how many routers that you have. But for BGP or when we have some carriers, there's a big database, we're going to provide a service, or we are a service provider, internet service provider. So we do need BGP for our routing protocols. There are some reasons. The first reason is that the BGP is live. You can check if the system is live, and the troubleshooting, everything is different, but still it is a routing protocol. And the first thing which is important, we have autonomous system, AS. So maybe 100 routers, 500,000, I don't know exactly, are inside one autonomous. This is something that you have to, for example, in Canada or North America, Eren.net is the company that's you're gonna register there, and you're gonna pay for that if you want to use something public for you or yourself. So you need that. Anyway, it depends on the routers that you have in a cloud, in a zone. So you have your AS, and you have IGP for the routers which are inside one AS, and the protocol that you have to use for this way, communicating between the AS, so it will be BGP. You can redistribute, but if you distribute your route, then you cannot use the BGP attributes, which we'll learn. Okay, so this is the thing that I was telling you. We have multi-homing in BGP, so we do need reliability in order to high availability of your system, redundancy. In case one connection fails, you need to have another one to have the continuity of service, and also the performance. So this is the concept of multi-homing, which is existed in the BGP concept, and the autonomous systems. So look, this is the thing that I was telling you. For connection between two autonomous systems, we have BGP, no matter what routing protocol that you are using inside your AS, REAP, ISIS, OSPF, EIGRP, and you do need the BGP, which we call it eBGP, actually exterior border gateway protocol. And you do need what? You need an AS. An AS is a collection of the networks under that specific cloud or zone. So BGP is used between autonomous systems, and like the other routing protocols, it has some sort of loop prevention. How? For example, imagine a route or network is going from here, goes from here, here, and will come back. As the router A sees that this autonomous system of that network is the same with itself, it's going to just drop the packet. So it has loop prevention. So BGP path vector routing. Why we call that path vector routing? We have something AS, as I told you. So imagine this is a AS, and this AS has these 3 networks, and this AS is going to advertise the networks over, for example, this AS to here. So the path advertised. Look, the first one is here. So this is the AS number of this AS, and then we have this one here, and then we have this one here. What does this mean? It means when a network is going to go out of AS, the AS number will prepend in the header of that network, which we call that path vector routing. And we can see in the routing with the command of show IP BGP summary, we can see the number of the AS that network passed through them to reach a specific place. So this is the concept of that. And then we have some routing policies for that. We call that AS by AS. This is the thing that I was telling you and I told you can support policy conforming hop by hop. So we're gonna see that for each network, we will see what will be the next hop and the characteristics of that. So BGP, it has the look is the most appropriate when at least one of the following things are existing. So we have a multiple connection and autonomous system. We have routing policies, and also at some specific places it's not appropriate. For example, you have limited understanding of BGP. Imagine you are not good at Asyas and you are good at IGP, and say, okay, for this network I'm gonna work on or I'm gonna run Asyas. Why you are not good at that? So as BGP is a big concept, and since it is very complicated in comparison with the other protocols, so if you do not have good understanding of that concept, do not work on that. Well, when you have a single connection to the internet or to the autonomous system, so there's no need for that. And also lack of memory, because it's gonna consume lots of process. So the characteristic, it's a path vector protocol. It is reliable, and I mean the updates will see if we try to use debug IP BGP events command or IP TCP debug IP TCP transactions, we'll see the communication for the BGP will go via port 179. Incremental and triggered updates. Look, for example, in a RIP routing protocol, every 30 seconds, the router will send all of the networks that it has in its routing table to all of the neighbors. Or in OSPF, we have something somehow the same. But the point is that in the BGP, it works just based on the updates. And so it's not going to just advertise all of the networks that it has. It works whenever there's a trigger. So, okay, something happened. I'm going to update you. Something like that. And it has a pretty keep alive message. And so it is perfect. And you can change that time for the keep alive. I'm going to show you on the commands. And it is reach metric. And it's for a huge scale whenever. So you have I told you have lots of carriers, or you have your internet service provider. So what is the database? We have a neighbor table. It's important to see your BGP neighbors. You should first advertise them, introduce them to the router, and then so you have your BGP neighbor. I have the BGP table list of all of the networks that it learned from each neighbor and can contain multiple paths. And the BGP, it is so smart. It will tell you which path will be the best path, and in the end it's a IP routing protocol. So all of that concept will be derived into routing, and you can see that in show IP routes. So we have BGP message type. BGP defines the following message type. It has open, keep alive, update, and notifications. So includes a hold time, and the keep alive, I told you, you can see that it's alive for updates. So whenever there is an update, it will send the update, and notification, you'll receive the notification whenever error detected, or the BGP connection is closed. What is the summary of whatever I've said so far? So the network is the multi-home, and the monitoring, you can monitor all of the packets. You can see, you can even add a security encryption for that. You can change the keep alive time, and it is for the autonomous systems, and it's forwarding and it's gonna forward on some policies based on the thing that you're gonna tell, not the best path. And also BGP routers exchange network reachability information. I'm gonna again show you that, but anyway, just read the things and just try to understand and learn the concept. So let's go. BGP and IGP. We have BGP, it's a border, it's for your edge routers, and IGP, it is the routing that you are using inside. So here for the IGP, you have your OSPF, and here for the edge routers, you have BGP. So these two are BGP neighbors. But inside an AS, you do have to have the BGP, which we call that IBGP, interior BGP. So the network or the network inside an AS should be fully meshed. This is an important concept. You need to have both IGP and IBGP in order to have what? In order to have a correct BGP running. If not, you'll see the updates, I don't know, will not pass through your network, or there are many disconnections, something like that. So we call that, we have peers or neighbors, we call them BGP peers or BGP neighbors or BGP speakers. Any two routers that have formed a TCP connection to exchange BGP routing information are called BGP peers, like these. What is external BGP? I told you this is the external BGP. So when BGP is running between two neighbors that belong to different autonomous systems, it is called eBGP. And eBGP by default need to be directly connected. There is a command in order for the situations that they are not directly connected, but the basic concept is that the edge routers are directly connected to each other. IBGP, transit AS. What is transit AS? Here, imagine at that part there are many networks, routers, and all of them is going to pass through this AS to reach the other one. So this AS, it is the transit AS. We can have redistribution here, but the point is that it is not recommended, and we need IBGP for that. I told you we have a BGP attributes, and it is important to use BGP attributes in order to have lots of variety of options. So BGP in non-transit, look here, it's good. It's a good example to take a look at that. If we have BGP here and this network is not fully meshed, it's partially meshed, there is an update or something like that. Let's think of update just now. There is an update. It is going from here, goes to here, and based on BGP, router B will receive that, and the router B will send that towards router D and C. But due to loop parentation concept of the OSPF or all of the routing protocols, neither router D nor router C will update or will send that information to the router E. So on the whole, that update will not go towards router F. This is an important concept that you should bear that in mind. So, but here, when they are fully meshed or they are fully BGP meshed based on IBGP, the update will go based on the path that the BGP routing protocol will choose as the best path. So the summary, the key term to describe the relationship between the running BGP are as follows. We have BGP speaker or BGP router, we have BGP peer or BGP neighbor, and we have IBGP inside an AS and eBGP outside an AS. So eBGP neighbors are directly connected routers in different autonomous systems. Autonomous system number 1, number 2. The edge routers are directly connected, so there are eBGP neighbors, and IBGP neighbors are the routers inside an AS which is not supposed to be directly connected. So basic configuration. So Now we know the basic concept of BGP. Let's go for the basic configuration of BGP. The first command, just what do we need to do? We need to type router BGP, the autonomous system number. Look in OSPF or EIGRP, we just type router OSPF or router EIGRP, and then we come up with a number, which should be the process ID. And on a router, on a single router, we can have many OSPF and EIGRP with different process IDs. But here, in the BGP, we are not supposed to do that. Just we have one router BGP, just one, with what? With the AS number, autonomous number, that we are inside that. This is the concept, the first concept of this command. This command enters router configuration mode only, so the subcommands must be entered afterwards to activate the BGP. And yeah, I said all of them. Anyway, good. So after that, router BGP, for example, 1, then we're gonna advertise the networks. So BGP, look, neighbor, we're gonna come up with IP address of the neighbor and the remote AS. So this is the concept of eBGP and iBGP. We do not have different commands for eBGP and iBGP. How we can distinguish, how we can understand when we are looking at the result of show IP BGP summary that this network or this routing is from iBGP or BGP? The AS number. So if the AS number is the same with yours, so it should be iBGP, otherwise it is eBGP. This is the example of that. Imagine we're going to connect these two as iBGP. What do we have? Let's take a look at this one first. So we have router BGP 65101, which is this AS number, and the neighbor 192.168.1.1. Where is that? This one. Like the how we in the static routing we used to say or we used to write IP route the network and the next hop on the peer router. So this is exactly the same. Neighbor, this is the neighbor, I mean the peer router or the neighbor network, and the remote AS is this number. So when this number is not similar with this number, what does this mean? It means this is eBGP. And also we have neighbor 10222, which is here, this interface, and with the same AS number. So this one is iBGP. This one is eBGP, iBGP, and the configuration is the same for the rest of them. So neighbor shutdown command, in a situation that your interface just goes up, down, there are some penalties that the main controller company, or I don't know, the supervisor of the whole system, they're gonna put that to you. So there are first some penalties, and when your network or your route just goes up, that your interface goes up, down, and this is something that happens, I don't know, somehow periodically, that network won't advertise through the net, and this is a problem. So how you can solve your problem? The first step is to type neighbor IP address shutdown. So first you need to shut down that, and with no you can just do the negative thing. Example of iBGP peering. So it is another concept, and it is good to learn. Imagine this cloud of networks, routers. We have a router A, B, C, D. And what do we want to do now? We want to make iBGP between router A and router D. We should so come up with that. Router BGP, this AS number, and then neighbor. So these are the neighbors. Actually, which one should be advertised? This network, or the loopback? This is a question. We can add all of them. For example, if we want to run iBGP in router D, and advertise or interview the router A. To that, we can type neighbor 10.1.1.1.1.1 10.3.3.1. But there is a problem. There is a, imagine a big network, a vast network. The first thing is that your BGP neighborship, it will be packed with lots of routers, with lots of networks. So it would be CPU consuming, and there are many things, that many processes, many calculations. This is the first thing. And the second thing, which is I was telling you at the beginning of that slides about multi-homing or reliability, what will happen if there is an update from this interface, and this interface is going to go from here, and accidentally something like that, this link is going down. What will happen? This link is done, and your update will be failed from the router A, because this interface is going to advertise, or it's going to send the update. So while this link is done, there won't be any update for you, and okay, you will lose that update. And this is the thing, that if you just add the loopback interface and mention that loopback interface as a next hop into your local router, you'll receive updates while one of the links is down. So this is the important thing, that loopback interface is reachable. For example, loopback interface of router A is reachable on router D. So if you add, instead of the interfaces, if you just add the loopback interface 0 and mention that as the update source, loopback 0 on the router D, so it will be good for you, not mentioning the interfaces. This is the command. Look, neighbor, this is the IP address of that loopback, update source, interface type, your loopback 0. This is the concept. And what is the next hop behavior? So in the BGP, we have AS by AS routing protocol, and not a router by router. It is very important. In BGP, it is AS by AS. As I told you, when a network passes one AS, the AS number will be prepended on the header of that. And in the BGP, the default next hop is the IP address of the neighbor router. But in the BGP, the next hop does not mean the next router. It means the IP address of the next AS. So from here, we know about the concept and basic configuration of the BGP. And the second part, in order not to be tiring or time-consuming videos on the YouTube, so on the second part, I'm gonna talk more about BGP. Bye everyone, stay tuned and wait for the second episode.